right, today what we're working on is we're going to actually shift some of these graphs left and right today. So we're going to graph these quadratic functions, and we're going to talk about domain and range, and we're going to talk about some different analysis of the graph. So the format we're going to use today is going to be vertex form. So just to remind you, it's a times x minus h squared plus k, and hk is going to be your vertex. And what's going to go on here in terms of how this looks, this is going to work just like the absolute values. When you do the vertex, it's going to be the opposite of what it looks like is going to be your x-coordinate, and then we're going to copy the y. So inside with the x is going to change the x-coordinate of your vertex, outside is going to change your y-coordinate. So inside goes left and right, outside goes up and down, and inside it's the opposite way that it looks. So let me slide this up here real quick. This looks like a -2. So +2 is actually the x-coordinate. It's what sets that equal to 0. You switch from one side of the v to the other. The y-coordinate, you just go ahead and copy what's on the outside. So, whoops, that's going to be 2, -3. Now, out in front of the parentheses here is your a value. Since I don't have something written out in front there, but it exists, it's just going to be that my a value is 1. So my pattern is just the 1, 3, 5. So I'm going to find my vertex, which is 2, -3. And just from that point, over 1, up 1, over 1, up 3, and then over 1, up 5 will fit on the graph here. And I'm just going to do my best to U-shape that. All right, now I'm going to write down the vertex and the pattern, and then I'm going to go ahead and pause the video and graph the second part here, but opposite copy, so -4, 6 is going to be my vertex. Now, out in front here, I have a negative, so I'm going to multiply all the numbers in my 1, 3, 5 pattern by -1, and this is going to turn the graph upside down. So from that vertex, I'm going to go over 1, down 1, over 1, down 3, over 1, down 5. So I'm going to pause and do that, and you guys go ahead and do the same. And here's my graph, -4, 6, over 1, down 3, down 5. Your graph should look like that. What we're also going to work on today is analyzing the graph. So here's the general form, your vertex form like we have at the top. The maximum or minimum value of the graph, it's one or the other, is going to be the y-coordinate of your vertex. If you have vertex form, that's just going to be the k value, and that's the actual value. You're not writing down the coordinates of the point, it's just the y-coordinate. Axis to symmetry is going to be x equals h from here, so it's going to be the opposite of what it looks like. It's going to be the x-coordinate of your vertex, x equals x-coordinate of the vertex. The horizontal translation is going to be left or right, and that's affected by the h. The vertical translation is going to go up or down, that's going to be the k. The stretch or a shrink, okay, so let me write this down. I'm going to ignore the negative if I have a negative. So negative tells you whether the graph turns right side up or upside down. Ignore the negative. If that a value is bigger than 1, you have a stretch. If that a value is between 0 and 1, like a 1/2 or a 2/3, you have what we call a vertical shrink. Now, domain, -infinity to infinity, goes left and right forever, doesn't matter the direction it turns. The range, I'm going to write two things. If the graph turns right side up, your range will start, the first y value you would touch is going to be the y-coordinate of the vertex, so that's going to be k, and then it goes up forever, so it would go up to infinity. If your graph turns upside down, then the graph approaching from the bottom would go down forever, so -infinity is where you would start for your range, and then the last point you're going to touch is going to be the y-coordinate of the vertex. So the range is going to depend on the direction the graph turns. All right, so we're going to go through and analyze this graph. So I've got it on the paper for us already. The vertex, you guys can actually either identify from the graph or you can use the equation. Remember, this is opposite copy. So this is negative 6, 8. Now, you guys can see from the graph here, this turns upside down. So this is going to be a maximum. The axis of symmetry, it's going to be x equals negative 6. That's that nice vertexal line that goes right down the middle of your parabola. Now, your horizontal translation, we're thinking about from the parent function, which would be y equals x squared. So that would have a vertex at 0, 0. So the horizontal translation is that I'm going left 6, and then the vertical translation is that I'm going up 8. Now, the vertical stretch or shrink, if you guys look here out in front, remember we're going to ignore the negative. The negative just tells you it goes upside down. That's a reflection over the x-axis. But because this is a 1/2, this is going to be a shrink, the 1/2. And in terms of your domain and range here, all these negative infinity to infinity. For the range, if I'm approaching from the bottom of the graph, I'm always touching part of the graph. So the range is going to go down to negative infinity. And then the last value I touch here, the last y value I touch is going to be 8. So the range is going to top out at 8. All right, and then here on the back, I'm going to actually have you guys graph this. So that one on the front, I provided the graph. So we're going to graph this. So first thing you always want to find is your vertex. So opposite copy. And so negative 1, 6 is going to be my vertex. So let me go ahead, or sorry, negative 1, negative 6. I'm going to go ahead and plot that point. Now, my pattern is affected if I have a number out in front there. So my pattern is going to be 2 times my 1, 3, 5. So the pattern I want to use to graph this is going to actually be 2, 6, 10. So from there, I'm going to go over 1 up 2 on either side of that. Over 1 up 6, and over 1, 10 is not going to fit, so that's where I'm going to stop and go ahead and connect up my U. Alright, so there's a good picture of my graph. Now, axis of symmetry, I'm going to go ahead and sketch this in real quick so you guys can see it. So that splits the parabola into 2 equal pieces. It's always x equals the x coordinate of the vertex. So here it's going to be x equals negative 1, nice vertexal line through negative 1. This has a minimum value because the vertex is at the negative graph, the vertex is at the bottom of the graph. The actual value that you would want to write down would be the y coordinate of the vertex, which is going to be the negative 6. Now, horizontal translation is left or right from 0, 0. So this is moving left 1. And if I do that, then I'm going to go down 6 to get to that point. So the vertical translation is how are you moving up or down? So then this one's going to be down 6. Now, vertical stretch or shrink, if you guys look back up to the equation, let me pull this down a little bit. That's that number I highlighted. This is 2. So ignore the negative. This is going to be stretched out from your y equals just a plain x squared. This is taller and more narrow, so this is a stretch. Domain for every single one of these is going to be left and right forever. So your sides of your parabola, this will go left forever. This will eventually go right forever, so you cover the whole x-axis. Your range here, if you come from the bottom of the graph, the first y value that you touch is negative 6. That has a bracket because there's an actual point there. Everything else goes up forever, so that's going to go up to infinity. And if you guys want to pause the video and try this on your own, I am going to walk through it, but if you're feeling comfortable, you might just pause the video and then pick it back up once I've filled everything in and try it on your own, or you can work through it with me. If you want to pause, do that now. I'm going to go ahead and work through this. So vertex opposite copy is going to be 3, 7. So I'm going to go ahead and go over to my graph and plot that point. The pattern here is affected if there's any number out in front of those set of parentheses. So I'm going to do negative 1/2 times my 1, 3, 5. Now, the pattern I want to use, and remember, I want to recommend do a decimal. This is going to be -1/2, -1.5, -2.5. And so let me come over to my graph here. Always just go over 1, and I'm going to go down 1/2. So I just estimate where that would be. From there, you're going to go over 1, down 1.5. We'll put you right on a nice point. I've got 1, 5, and then 5, 5. And then over 1, down 1, 2.5. And then I'm just going to do my best to make a U shape here. It's a good sketch of my parabola. This is going to be a situation where the graph is a shrink because we're going to compress it and it's going to be wider. Let me go ahead and draw in the axis of symmetry here. There's my reflection line. If I folded it in half on top of that, it's a nice vertexal line. Looks like the x value there's 3. This guy is having a vertex at the top of the graph, so that's going to be a maximum. The actual value, like the highest value of y in this graph is what you want, just the y coordinate of that point, it's going to be 7. Now, your translation, you want to think about going from 0, 0. So if I go from 0, 0 to get over to this point for my vertex, I'm going right 3. Vertical translation is up or down, so we need to go up 7. So that's going to be my vertical translation. And I'm going to scooch this up just a little bit. So the stretch or shrink. Now, ignore the negative. The negative just turns the graph upside down. So the number I'm looking at there is the 1/2. I'm ignoring the negative. That is between 0 and 1. So remember, if that a value is between 0 and 1, 1/2 would fall into that category. This is a shrink. And what happens with the shrink, it widens the graph out, it compresses it. Domain for all of these is, this is -infinity. So this would go, it points down, but it goes to the left forever. This points down, but it goes to the right forever. So you would cover your entire x-axis. Now, for the range, come from the bottom, this would point down forever. So I want to start my interval at -infinity because it would go down to -infinity. Here, as I go up the graph, I stop at a point. So my maximum value there is that 7. And we go ahead and put a bracket because we have an actual point there. And that's all there is to this set of notes.